Had this question about homework number 4B, is that right? Okay, or 46, I guess. It's probably 46. Hey, did you have this question? Okay, I get it, but you gotta remember, I gotta find a balance between time of practice in class and getting through the content so that you can have all the stuff you need to be successful. So, I'll try to do a little bit more, but we gotta find that balance. So that's where the AP free response questions come in. But also, those bell ringers where you ask a question about a specific problem that you have already tried is a lot of what the practice is. So, first things first, I need us to pay attention to this. During a flu vaccine shortage in the U.S., it was believed that 45% of vaccine-eligible people received flu vaccine. The results of a survey given to a random sample of 2,350 vaccine-eligible people indicated that 978 of them received the flu vaccine. Construct a 99% confidence interval for the proportion of vaccine-eligible people who had received the vaccine. Use your confidence interval to comment on the belief that 45% had received the flu vaccine. What is the first thing we gotta think about as soon as they tell us to construct a 99% confidence interval?
Check the three, what you call it?
Conditions.
Yeah, that's.
Even before that.
Random.
Even before that.
Normal curve.
Even before that.
Put your name on the paper.
Guys, it's a 4-step process, we gotta know.
Isn't it already stated for you though? Like,
It doesn't matter. You gotta state it. I'm telling you the AP exam, here's the thing. Every now and then, it's implied and they don't expect you to state it as a part of the scoring rubric. But there's never language that you can tell whether to state or not, so just state what it is. So what would the state here be?
would you just be saying you're constructing one proportional Z interval?
I would say 99% one proportion, that would work, Z interval, but there's one thing you're missing, and it's the context. With the state, you gotta tell what level, you need to tell me what type of confidence interval and what the context is. So for what?
The percentage of vaccine eligible people who receive the vaccine. Or I guess proportion.
You can say either one. Typically we do write as a proportion. This would probably be enough context. I do think it was in, it was in the US. The next one's Canada, got it. That's what I was thinking about. Vaccine eligible people in the US who received the vaccine. Now there's one word I threw in here that Ashton did not have that we need. Does anyone see the one word I threw in that Ashton did not use? True, right? We gotta make sure it's clear that it's a population proportion or the true proportion that we're talking about here.
Okay.
So state. And so that's a big reason why we state. Also, when you state it like that, that's gonna help you later when you conclude to make sure you conclude it correctly.
Okay.
Right? Plan. What's the plan then? This is where the conditions come up that y'all were talking about. But does anyone remember what I like to write to help me remember what conditions to think about?
I just remember the conditions.
I know. You don't have to write this part, but I recommend it. I write out the formula. We said it was a 1 proportion Z interval. What's that formula?
The square root of
You're jumping. The
the
full interval.
the statistic plus or minus Z
So the critical value.
times the standard error.
And what's the standard error for p hat?
Square root of p hat times 1 minus p hat over n.
So one, that's going to help you with your do section in a second, right? So that's one reason why I write that formula out. 2, it helps me remember those conditions. What is the condition associated with our statistic?
The condition is
The bias, so randomness.
There we go, right? Like P hat's gonna suck unless we have reduced bias. Our sample needs to come from a random sample. Do we have randomness?
Yes.
Yes, so random, check, right? Random sample. Circling that, make sure that it's clear you understand it, right? What's the condition for Z star, the critical value?
Normality.
Normality, what do we need for normality?
Large counts.
Large counts, there we go. Yeah, we're remembering. So n times what?
Proportion of p hat.
P hat, there we go, is equal to,
Should be greater than,
but what's it equal to this time?
out here, of 978.
Remember how that's my expected numbers of successes, so I don't even have to do any calculations.
Yeah.
N times P hat will be 978. Is that greater than or equal to 10?
Yes.
Yep. So what's N times 1 minus P hat? Well, that would be my expected number of failures.
2350 minus 978.
Yeah, what is that? 1350 plus 22?
Which one is this one?
I mean, the first one's bigger than 10, this is a
1350.
bigger proportion, then it's obviously bigger than 10.
Mm-hmm. And I will say this, I've asked that question before, can you just check the smaller one? And as long as you note, hey, that's the smaller expected counts, so it satisfies large counts, they'll accept that. But it is easier, just go ahead and be safe.
Yeah.
Yeah. Because I had the same question. Yeah. So then what's the condition here?
Last one should be 10%.
10% condition, right? Is our sample size probably less than 10% of the population?
Yeah.
Yeah.
Hopefully.
Yeah, 2,350 is less than 10% of all US adults. Is it all US adults?
It's all vaccine eligible people.
There you go. Oh, so it's even more than adults. All right. We got state, we got plan. What time is it? Do. Do the do, right? So if we're gonna do this, what are we gonna do?
Doing what? Oh, at this point, this is kind of what I cut into. So,
Mm-hmm.
to see, my statistics should come out to like 4.161.
Mm-hmm.
So I use that as like the thing that I put the plus or minus around. So that'll be like the center of the interval.
Yeah.
And then from there, your critical value, I put in.
So one thing, just to point this out and make your life easier, you know you don't have to get the decimal, right?
I don't.
No. You can just literally write 978 out of 2,350. That is P hat, isn't it?
Yeah.
Just leave it that way.
Oh.
It's just like, oh, that makes life easier, doesn't it?
Yeah.
Yeah.
But like significant.
Significantly. Okay, plus or minus.
You'd have to make the drawing.
Yeah. So here's the thing, you don't have to, but it helps if you don't already know that critical value, right? So, quick sketch of my normal curve. You got it, Charles, thanks. Alright, what do I do with that normal curve? Who is it?
Office Secretary.
Okay.
Hello, Mr. Kenny's room. The
She
neighbor's
was.
here, right?
Yeah.
Yeah, she's here. Thank you.
Alright, so how am I gonna use this to find that critical value?
You're gonna say
The
yeah.
middle would be 0.99.
Right, the middle is 0.99.
So it'd be 0.005
Right.
on each side.
We know it's 0.01 on together, so this one little piece is 0.005.
Yeah. And then you send that into this what do we call it?
The inverse multiple, right?
You should get
So-
negative 2.57583.
Yeah, you do. Negative 2 point, or, because we already have plus or minus, we can just do the 2.576 is usually where I cut it. And so even here, Ashton, I don't need the decimal, so I'm just gonna write it this way. Now granted, I actually know this already because of that 1372 I did up here,
Yeah.
so I could just write that 1372 out of 2350, all divided by 2,350. And now I'm plugging that joker into the calculator. So don't forget, state, plan, do, conclude.
Okay.
So what interval do we get?
I think I got like 0.3899, 0.4424,
Say it one more time. That's what I go.
like 0.3899,
0.3899 to,
0.4424.
okay? And once you practice this, this goes way quicker, right? So a couple practice, you just make sure you do the state plan, do conclude, it starts moving. So what would we conclude here?
With 99% confidence, the true proportion of vaccine eligible people who received the flu vaccine, or no, we're talking about the belief, because it's asking us about the belief.
That's part B. Or no, that's later. I would conclude and then tackle that idea.
Alright,
So with 99% confidence, and you can start it out as this interval captures that parameter, or you give the context and then the interval captures it. I was just gonna do this because it follows the book format. So the interval 0.3899 to 0.4424 captures the true proportion of vaccine eligible US people who got the vaccine. Okay. So notice I did put a so in there, because we are trying to answer the question, what do we believe, right? So what do we believe about that 45%?
Okay,
it's false.
Yeah.
chances are,
Why would we believe why do we conclude that belief is probably false?
it falls outside of our 99% confidence interval, which means that it's extremely unlikely.
Right? 99%, like with 99% confidence, we should be capturing that value, but the entire interval is below that 0.45, right? So it's not one of my plausible values. So you can say either one of those ways. The entire interval is below 0.45, or you can say 0.45 is not one of the plausible values. So we doubt this belief as the entire interval of plausible values.
The confidence level thing is a little weird to me because if you know that it's capturing it 99% of the time, then you already have to know the true proportion to
So-
confirm that.
You don't, because remember, the 99% confidence level is about the idea that if it's a truly random sample, and I do multiple samples, right? In the long run, 99% of the intervals will capture the parameter. But that's why, like, if it's not random, I have zero confidence in the interval in the first place. And it's about the method, it's not about the interval itself. So 99% of confidence intervals in the long run, using this method, will capture the parameter.
As long as it's truly random.
As
Alright.
long as it's truly random, as long as bias was reduced. Right. Because if we have a biased sample, my data's crap and it's not useful, right? So like when we did these individual data points here, right? If I had done a confidence interval around these data points, 99% of them would have captured the parameter, right? But here, based on these data points, 99% of them would have captured this value, which is not what the parameter is, right? Most of these would miss the mark, even with a 99% confidence interval. Does that make sense?
Yep.
It's
I see.
about the method, not the interval.
Alright.
And that's something that took me a while to understand
I
as
think
well.
I got confused with large count. So do we take the, like, so in this one, we took 978. And so it was greater than 10. Are we-
So
Okay,
n times p hat, notice these cancel. So I'm just left with what?
no,
And that's why you've heard me say it pretty regularly of, it's the expected successes and expected failures, right?
yes, sir.
And so I already know what the successes were and what the failures were. Does that make sense?
I was looking at it, and then I think when I was doing it at home, I kind of found myself getting in the rhythm of doing that, and I was like,
Mhm. But why?
is it?
Yeah.
Yeah, why is it?
And so like, here's the thing, can you actually write what n is and write what p hat is and then get that calculation?
Yes.
Yes. But this can save you a little bit of time and you will be rushed on the AP exam. So,
If
there
it-
are times when you will have to actually multiply it out, and that's what we're gonna see in the next chapter.
So the second one, that's basically just saying, this is what's left over from the first one?
Yeah, because it's the expected successes and expected failures,
Yes, sir.
right? Think about it being binomial, because that's essentially what it is, or binary.
Yes, sir.
Either a
So
success
it's like
or a
a
failure.
compliment to the first one.
Correct, yeah, 1 minus p hat is the complement.
Yes, sir.
Alright, let's talk about B really quickly. So questions first about A. Peyton, you with us? Okay. We good on A?
Yeah.
Okay, B. Suppose a similar survey will be given to vaccine eligible people in Canada by Canadian health officials. 99% confidence interval for the proportion of people who will receive, or who will have received flu vaccine is to be constructed. What is the smallest sample size so that the margin of error will be less than or equal to 0.02? How are we gonna do this?
So the first thing I do is I set up that, the confidence interval, not confidence interval, the margin of error equation.
Yeah, I'm gonna set up that margin of error expression, set it less than or equal to
Point oh two.
0.02. And so, remember, the second half of that confidence interval expression is my margin of error. So, nice thing is, we already did 99%. What is that Z score?
Should be 2.576.
Times the square root
Do
of?
we have to put the negative this time around?
No, because we don't want to use a negative in this case, because we just want to know what n is.
Yes, sir.
Can n be a negative?
No.
N is sample size, right?
Yes, sir.
Good question, though. So what am I going to put inside this radical?
0.5 squared over x.
So remember, if we want to guarantee, we cannot base it on what we had previously. The guarantee, as Joseph talked about yesterday, is that 0.5, that maximizes it. Divided by n is less than or equal to 0.02. If it asks you for that margin of error and that guaranteeing that maximum margin of error, set that n or that expression, margin of error expression, equal less than or equal to whatever it is. And then just solve.
Mr. Kenny, watching you solve these problems so fast is like really pleasing in my mind.
Okay. It's interesting. I'm just using inverses. I have no clue what 0.02 divided by 2.576 is. It's probably a nasty, ugly number. No big decimal. No, not as bad as I thought. Okay. And then squared. I'm gonna just write down the estimate, but don't forget to use the actual calculator value when you do the next step. 0.5 squared, less than or equal to. Is it 4 zeros?
Yes, what I
So 0.5 squared divided by that. N needs to be greater than or equal to 4,148. just using inverses. Now, please make sure you know how to use the entire decimal from the calculator. This is only showing 0.00006, but you can get that full decimal by scrolling up. Yeah. So, yeah. But notice I take that 0.02. So you see how it gives me that decimal right there?
Yes, sir.
So I'm gonna hit up, enter, bring it down, because that's the full decimal squared. And that's all it shows, right? But when I end up doing that 0.5 squared divided by, I'm gonna hit enter and bring it down. Okay? How we feeling? Okay. One thing to be aware of, Josh, on this one, even though I think it's like a 0.36, isn't it? Is that what you got for the decimal?
For what?
When that in, 4,147.36. Isn't that what you got? Or no?
No.
Did you get exactly 4,147?
No, it was like four, it was like 46 point something.
Okay, so, cool. Then you would have been fine. They probably would accept it, but what I got was 4,147.36, and so that's why I let it be 4,148.
I think I was using like the exact calculator values.
That's what I did. I don't know,
Mr. King,
just slight difference, it's fine.
may I ask a question?
Yeah, go quickly. Well, we're about to start the demonstrating understanding. Be quick. Alright. Clear your desk of everything but the formula sheet and the calculator. This is the most empty this class has felt either ever or most recently.
There are more people here during the sabbatical.
That's what I was thinking. Alright, I think this demonstrate your understanding should take about 25 minutes, but I'm still finishing working through the solutions, so I may update that time, we'll see. Wrapping up, don't forget that I'm going to be collecting, which I think some of y'all were out when I said this again, so I'm not holding on to it today. But I'm collecting the Frere models on the day of the demonstrate your understandings from now on. That way I can give you feedback leading up to the test. Like I think y'all walked out before I said that the other day. The bell rang, that was my fault, that wasn't on y'all. So let's try, and like it also means that you have less to do at a time. So I'm not saying the entire Frere model, just the stuff that goes with what we've already studied.
Oh,
Does that make sense?
yeah.
You good with that, Tyler? You give me a look like.
Like now?
No, that's what I'm saying, I'm not holding you to it today, right now. But what I would ask is, and I won't hold it to you tomorrow, I would ask that you try to get it done tomorrow, by tomorrow, so that you can give it to me, I can give you feedback over the weekend. But I will ask for it to be done on Monday. Okay?
I've got the stuff we've gone over, we haven't gone over everything on the program.
Correct. So like this demonstrate, so what you need to have done is everything that was on the demonstrate understanding. We didn't do 8.3 on the demonstrate understanding, so you don't have to have had that portion done.
Yeah, the two proportion stuff.
Correct. Does that make sense? So so like when I collect it on the demonstrated understanding, you just have to have what we've covered to that point.
Alright.
All right, so let's go over this. Bryce can grab that. It's not over this, but let's get started with today's bit of lesson. So we did this yesterday. This is one of the the last thing of notes that we did, I believe. So grab those out if you want, or your Frere models. We're just going to recap a couple of details and then get going. And definitely make sure you're here tomorrow, because tomorrow we get to do fun stuff with Skittles.
Oh, okay.
We get these.
Today I'm not here.
We'll get to eat Skittles, huh?
Today I'm not here.
I know, I'm sorry. It should be tomorrow, maybe Monday, it depends on how quickly we go, but the plan is tomorrow. I might give you some Skittles today.
I might be back Monday morning. I just won't be awake if I make it.
Well, yeah, I'm talking about tomorrow, you won't be here tomorrow either.
Yeah, I
will
won't
you?
be
Yeah.
tomorrow.
So, alright. So, don't forget the name of the procedure we use when calculating a confidence interval for a difference in two proportions, not on the demonstrated understanding, but it would be called a what?
Two proportion Z interval.
Two proportion Z interval. You can also call it, in the book, they call it a two sample Z interval for a difference in proportions or something like that. So two sample Z interval for a difference in proportions. Random 10% large counts. Do you have to check it for just one or for both? You gotta check it for both, right? So the random condition, the large counts condition, the 10% have not changed. Remember, the 10% is for your standard error, the large counts for normality, for your critical value, random for your point estimate, your statistic. The one thing to also remember when it's two proportions like this, it has to be independent random samples, right? One sample cannot affect the next. Make sense? It cannot be related. I think we did the standard error yesterday. That's what we ended on. Is that right?
I think we ended on specific formula.
Oh, did we finish the specific formula?
I have it written down.
So what was the specific formula for that two sample Z interval?
It said P1 at minus P2 at plus or minus Z star square root P1 hat in parentheses 1 minus P1 hat over N1 plus P2 hat in parentheses 1 minus P2 hat and over N2.
Oof, that's a whole lot, isn't it? But don't forget, if we understand that it's a point estimate or a statistic, we know we want to estimate P1 minus P2, so there's the statistic for it. What is this overall thing called again?
A margin of error.
A margin of error, and that margin of error is made up of a
Z's or
Critical
critical
value.
value. And it is important that we say critical value next unit. We're going to talk about what are called t-scores and t-distributions, which is something unique to some means, okay? But we'll explain why there. But critical value times what?
That is a standard error.
Standard error.
Difference in standard errors.
And so remember, the statistic, easy. Critical value, easy, right?
Yep.
The standard error is the toughie, but we don't have to memorize it. Where is it? On the formula sheet, right? So take advantage of that formula sheet for that standard error. And remember, it's only one square root, because what do we have to add together? The
The variance.
variances, right? So, I really should say standard error here. So yeah, we're to get P1 minus P2, right? First off, we never subtract, we only add, spread, and we have to add their variances. Okay. Questions through that portion of two proportions interval? Did we do this question very quickly at the end?
Mm-hmm.
Not at all? Sweet. Alright, let's do it. Yeah, let's do vertical surfaces. Looks like some of us need to wake up. Just a little bit. I mean, you can sit VSAT and sit at your desk if you want it.
Someone's phones are here.
Yeah, they left it from first block, they'll be back. What do you need to think about?
4 steps.
The 4 steps, what are the 4 steps always for inference? State, plan, do, and conclude, right? So state, what are we stating? The type of inference. We are doing a what?
Two proportion, Z interval, Instagram usage among adults, what the difference from 2021 to 2016.
Okay. Is there something else we need to add to that? Or are we good with all that?
I think a 95% confidence.
I would also include, that can come into the plan section as long as you mention it at some point. And so I will say this, state plan do conclude, those 4 steps are not something that's like, you have to write it out in that way, but you need to hit all of those ideas at some point for the AP exam, right?
Okay.
So you can put that either in the state or the plan, I always put it in the state, right? It's a 95% confidence interval, and this is the way I wrote it, 95% 2 sample Z interval for the true difference in the proportion of US adults who use Instagram from 2016 to 2021, okay? And so we're looking at that difference. Couple of notational things I want you to notice that you can do is this. Really quickly, let me stuck in right here. Also, because mostly I'm saying that because I'm recording. Sorry, I could have made that more clear. Anyways, what I was going to say is this. What you can do is just label these things. So I can label, just making a note of, hey, that's P1 hat, this is going to be P2 hat. And then you write it however you want, right? Ashton, you're like, I want to get a positive value. So I can do this, right? And just rewrite it this way. Make sense? Okay. What you can also do, and this is actually something I recommend, is you can put some kind of context to it. For example, what am I very clearly doing now with those sample proportions?
You're labeling them by year.
Right, 2016, 2021. That's a very straightforward way to make sure that it's clear which proportions you're talking about. It can make things a little bit easier. So, just something to keep in mind. All right, we got our state, then we got to do our plan. Which plan? Do you have to write out this formula?
No, it kind of covers planning, so that's what I do.
I was like, I do because it helps in the planning, but you don't have to. What you have to do in plan is check our conditions, right? This formula helps me check my conditions, and remember my conditions. It helps me in the next stage of do, because I need to remember that that statistic has to come from what type of sample?
A random.
A random sample. Do we have 2 different random samples? Random sample and random sample. So randomness, right? Not CLT, random. Is that randomness met?
Yes.
Yes. This critical value has to come from what type of distribution?
Normal.
Do we have a normal distribution? Well, that's where large counts comes from, right? And I'll say this, I don't even know that I would do all these calculations. I'd probably just write this and like, is that going to be greater than 10? If it was smaller numbers, I might. I'll have to ask some people if we have to do those calculations, but hot dang, that's got to be greater than 10, right?
Yeah.
All the way through. So at least writing this out and just saying greater than or equal to 10 would, in my mind, would be sufficient. So we have a normal distribution and 10%. Is it safe to assume that 1,502 U.S. adults is less than 10% of the population?
Yes.
Yes. 1502? Yes. We good with all that? So we got state, we got plan, now we need to do, right? So, do we have to do all these calculations by hand?
No.
Is Mr. Kinney going to do all these by hand?
No.
Heck no, right? I love myself. I'm going to set up that formula, which is why my plan, I wrote the formula out, right? And make sure you label these things. And then I just substitute everything in. Remember that 95%, that 1.96, that's one of the ones we want to know. Set up the formula, and then I'm going with a calculator to calculate that true difference in proportions. We good with all that? We know how to type this in.
Yeah.
Just remember when we go to that calculator, right? We're still gonna go to statistics, we're still gonna go to inferences, but instead of a 1 prop Z interval, we're gonna do a 2 prop, 2
Mine is
proportion.
slightly off.
Huh?
Mine are off.
That was different from Ashton's as well.
Yeah, did you do these
Yeah, actually, I kinda did the,
calculations by hand?
Yeah.
Teachers and students,
So it could also just
for
be
those
from
of
the
you who are in the
1.96.
building, the Powder Puff game is now over, and the kids will be coming into the building right now. Just as a reminder, teachers, the juniors that have been coming to the theater for ACT work will continue that process today. So same teachers, just a different topic, and make sure that they come to the theater. They may have some confusion about that. Thank you very much.
So with 95% confidence, the true difference in proportions of US adults who used Instagram from 2016 to 2021 is captured by this interval, which I could have put the interval earlier. 0.0459. By the way, do you think that those numbers are close enough for the AP exam to be like, yeah, sure?
Yeah.
Do they have like a certain, like a specific range?
It's not as precise as like calculus. Remember, statistics is
From what you said, they're pretty lenient on the numbers.
right. As long as like it's very clear that you followed the correct procedures and you had very right ideas and your numbers are super close, they're going to be very lenient on those. The one thing I'll point out is this: do we have convincing evidence that the proportion of U.S. adults who use Instagram increased?
So I did mine from 2021 to 2016.
Either way, just look at that interval.
Okay.
Do we have convincing evidence that the percentage of U.S. adults who used Instagram increased?
Yeah.
Yes.
They're both positive.
Okay, so both values are positive, meaning that we don't think that what difference is possible.
The negative difference is possible.
Okay, not just negative.
Oh.
What would it be if there was no change?
0.
Zero.
It'd be 0. What did we not capture?
You didn't capture 0.
Right, so 0 was not a possible value in that 95% confidence interval. So do I have convincing evidence that I believe the true difference in proportions, or do I believe that it changed, that it increased?
Yes.
Yeah. And notice, even though I wrote it maybe a little bit differently, I did do the same thing that you did of 0.4 minus 0.32. That's how I got the positives. If it had been negatives, that just meant I flipped it, but it'd be the same idea. All right, don't forget you do have an AP classroom that is due today. Oh yeah, so part B, based on the interval, is there convincing evidence that the proportion of U.S. adults who use Instagram has increased from 2016 to 2021? The answer is yes. And so we'll pick up here tomorrow, and so we'll actually finish probably this information within the first 30 minutes of class, depending on how many questions Deacon comes in with. Or others. I just know Deacon comes in with a lot of questions, which is awesome, but all the time. Does he do that in calculus too?
You know, with calculus, it's more like a.
Everyone does.
Yeah, it is.